Chinmay, Khushi, Binish, tell me.
Good evening, sir.
Good evening, Khushi.
I had a doubt about that you explained the examples of frequency independent selection of over dominance and under dominance. In
Hmm.
that, the over dominance and under dominance were examples that were frequency independent. How can we say that
No, 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 no.
those?
Over dominance, under dominance are not frequency independence. So, over dominance is the scenario when the heterozygote is more fit than the two homozygotes. Under dominance is the scenario when the heterozygote is less fit than the two homozygotes. Now, so these things are properties of the genetic system, they are not properties of selection. When you have that particular situation of overdominance or and underdominance, and when that is combined with frequency independent selection, then those properties that I showed you, they happen.
Okay, okay. But my question was like if we take that example of flowers, that alpine orchid, black,
Hmm,
red, and white
hmm,
ones.
hmm, 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 hmm,
Bees were going to black and flies were to the white.
hmm,
So if we increase the frequency of red flowers and
hmm.
decrease the frequency of black and white one, so now the bees and flies will even go more to the red. So fitness of the red will increase. So it's like if we are changing the frequency, fitness will also change. So how do we
The,
say that?
the relative frequencies have to change, no? Only when you change the relative frequencies. If the relative frequencies are not changing, then it will remain in the same direction. So, so,
Relative.
so, okay, sorry, we are talking about which one? The alpine orchid, right? So that
Yes,
one
yes.
is not a frequency dependent one to begin with.
Yes, yes, that's what
Hmm.
I want to ask. It
Hmm.
was explained as frequency independent,
Correct.
but it can be frequency dependent. Now, suppose if we increase the red flowers frequency
Hmm.
and decrease the black and white flowers frequency. So now bees and flies will go more to the red ones. So the fitness of red ones will increase. I'm asking that you explain this example under frequency independent.
Correct.
But how is it frequency independent? I am not getting that point.
Okay. I mean, see, in this particular case, the red morph is intermediate between two, right? Now, so what is happening is flies prefer white over black, correct?
Yes.
Bees prefer black over white, correct?
Mm. Yes.
So, both flies and bees, they tend to go to the red,
Yes, yes.
correct, because they are getting both kinds of pollinators. Now, suppose you have increased the frequency of the red flowers, okay, that is the case you are saying, correct?
Yes.
Huh. So, what will happen? Their fitness is already high, their fitness will remain high. So, what is the issue here?
No, fitness will increase even more now.
Why? Why will it increase even more?
Mm.
See, why is it that the red is having a higher fitness? Tell me.
Because its frequency. No, no. Because bees and flies both are going to the red.
Exactly, because both pollinators are going there, correct? So,
Yes.
so now if you increase the frequency of the red flowers even more, what will change? The bees and the flies will still be going there.
No, we are decreasing the frequency of black and white ones also. So those
So
flies
what?
which were going to black and white now
No, no,
also
no.
going to red.
No, 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 no. See, there lies the whole point. You are assuming that their preference will end up changing. As long as the preference of the flies for the white flower remains the same and the bees for the black flower remains the same, in that case if you increase the number of red flowers, nothing will happen, right? Implicit in what you are saying is that if there are more red flowers, then both the flies and the bees would like to go more to the red flower. Okay. I mean,
Um,
think about it a little bit. You will realize that as long as the preference structures remain the way they are, if you increase the frequency of the red flower, nothing really will happen.
okay, okay.
Hmm. Chinmay, Binish, anything?
Sir,
Hmm.
thank you very much for the class. I don't have any questions because I have a lot of things to catch up. I
Okay.
don't have enough knowledge. I have to read a lot to learn things you're teaching.
Which
It's
week
very
are you?
interesting.
Which week are you in right now?
I went through. I went actually very fast. So I'm in the last week now, the one which published now, seventh.
We are already in seventh.
I,
Okay.
yeah, but I didn't open that one yet. Yes, because yeah, I'm in between work. A lot of work happening these days.
Mm-hmm.
So I'm still just finished one meeting and I just popped
Came
up
for
here.
this.
I'll have to
Okay.
back to the meeting. Yeah,
Sure.
and thank you very much because you have opened a lot of things in my brain and I have downloaded most of the books. I need to go through it.
Hmm.
Thank you very much, sir.
Thank you. Thank you. Good to know you are enjoying.
Yeah, I'm really enjoying, but I have to learn a lot.
Yeah.
Thank you.
Okay. Chinmay? Chinmay, do you have anything? Actually, there's Kritika. Kritika, you have anything to discuss?
So I had one more question.
Hmm. Tell me.
Uh, in the migration topic,
Hmm.
we assume that same number of individuals were going from population 1 to 2 and then same number were returning to 1.
Yes.
On the basis of that assumption,
Hmm.
we derived that frequency of both the populations will become equal at equilibrium,
Hmm.
that P1 is will come to P2.
Hmm.
But in actual life, it will not going to be the case. That was like it's not important na? That if five individuals goes from one population to another, then five from there will come back to that first population.
Hmm.
So then we use that P1 is equals to P2 in comparing that migration and drift. In drift, if there were we were when we were talking about many populations, so drift was increasing the variation
Hmm.
and migration was decreasing the variation
Hmm.
because P1 was becoming equal to P2.
P1 becoming equal to P2 simply means that the frequencies are
Their
becoming equal.
frequencies were becoming equal.
Hmm. Hmm.
Yes, yes.
Hmm.
So, but that was the case when number of individuals that n we were taking equal,
Hmm.
that immigration and emigration.
Hmm. Hmm.
Otherwise, that I don't think so. We
See,
have used that conclusion anywhere else.
the point is that if you continuously have the numbers not being equal, let's say from one population 10 individuals are going but only two individuals are coming from the other population, okay, then what will happen is that, assuming birth rate, death rate, etc., being similar, then what will happen is that there will be a population size imbalance, right? Because the population which is, you know, throwing out more population, throwing out more individuals, but getting less individuals in return, that population size will keep on going down. Correct?
Yes, yes.
So that is, if that happens, then you have a different kind of a problem, because then that will lead to a change in the P due to, you know, migration plus the fact that the, you know, total number itself is changing. Correct. And
Yes, yes.
so what you really need is, I mean, that is not also what happens, right? If that happens, then after some time one patch will become completely empty and the other patch will have all the individuals. That is a trivial outcome that will happen.
Yes,
Typically,
yes.
huh,
It
yes,
happens like individuals go from one to another, but it's not necessary they will return to that first one.
no, no, no. See, what I am saying is, suppose think about it from a modeling perspective. If you are always modeling that, you know, let us say 100 individuals going in one direction, but 10 individuals coming in the other direction. Okay. Then the population in which there is a net loss, after some time that population will become equal to 0. The size of the population itself will become equal to 0, right?
Yes,
Because there is a net loss of individuals.
but it's not important na ki migration will happen always. Like it can happen only once,
Correct.
then it cannot.
Yeah, yeah. See, if it happens only once, that is more like a perturbation, right? That is not a migration event. I mean, then just one time some individuals went this side, that side, end of story. What is more likely to happen is that sometimes there is more individual in one direction and sometimes there is more individual in the other direction, right? Only then on an average it will become equal, correct?
Okay, but the examples you gave of migration,
Yeah, those are simple ones. Sorry, the example or the model, which one do you mean?
examples like that
Uh,
wolf one and all.
huh,
In that one, only wolf was coming once. Then they were setting up populations.
correct. But
So,
if you look at the context in which I discussed those, I was discussing them only in the context of inbreeding depression. And the fact that these migrations, these are, even if it is happening only once, it is able to, you know, reduce inbreeding depression, correct? But if you look at the modeling that I did with that, you know, one way, two way modeling and all that, those are not related to inbreeding depression. Those are related to how the frequency of a particular allele is going to change, correct?
yes, yes.
Isn't it? So those are two different phenomena that are being talked about. So, I did not give you guys any example of a particular allele, the allele's frequency getting changed because of migration.
This is that was where I was facing the problem. I was not able to relating the examples
Hmm.
with the model you gave.
Correct. So, that is what migration does, multiple things. Na? Migration obviously changes the allele frequencies, and it also has a role to play in getting rid of inbreeding depression. I only gave you examples of the second type. I have not given you examples of the first type. There are examples of that also. Okay. So, there are these snakes, okay, red banded snakes on different islands, and people have actually looked at what fraction is migrating in and what fraction is migrating out, and then they have tried to, you know, figure out what is the expected number of what is the expected allele frequency, and they have compared that with the observed allele frequency. The reason I did not give you that example is that in that example it is actually a migration selection balance example. Okay. If you only go by migration, you will see that the expectation is very different from what you actually observe. But when you then realize that the snakes that are going to the islands, they are facing a very different selection pressure, then you know, you realize that okay, now when you know, plug in that selection pressure into the equation, then the entire thing falls in place, which is why I did not get into that complication. I have not taught migration selection balance. No, that is why the example was not given.
Okay, okay. So means that case you gave that model of n
The
being equal that actually exists. That was not ideal case or something.
no. See, come on. How can you will get ideal case in real biological example, right?
Matlab,
Obvious.
not
Huh.
very ideal, but in somewhat sense it can exist like that
Yeah, yeah,
kind
yeah.
of thing.
Yeah, see, the problem is with any natural population, you will have multiple forces interacting with each other, right? You will have drift, you will have selection, you will have migration, you will have mutation, all of it interacting with each other. Therefore, getting an example which is pure migration or pure mutation becomes a little bit difficult. Pure selection is easy to get because selection is a very strong force. Okay, but getting example of only migration or only mutation becomes a little tougher. So that is why I didn't give you a real world case scenario of that one, but yeah, I mean it
Okay, sir.
exists. Hmm.
Okay, sir. Thank you.
Okay. Okay. Sure, Benish, no problem. See you later. Yeah.
Thank you very much, sir.
Hmm. Okay. Kritika, you have anything? Okay, great. All right. So Khushi, Kritika says that she hasn't got any doubts. So it's entirely up to you now. So if you have anything else, let me know. Otherwise, maybe we will just stop.
I think for now I have only this much doubt.
Okay.
Okay, okay,
How much?
one thing.
Yeah, go on.
Okay, one thing I was like in genetic drift, you gave those formulas, and for their derivation, you suggested a site where it was given the derivation.
Which one are you talking about? Which
Uh,
formula?
Genetic drift, that effective population size.
Right, right, right. I did not derive that for you guys.
Oh,
So,
yes, yes, you
hmm,
gave the site.
hmm,
So
hmm,
I
hmm.
have went to that site, but actually I did not understand. It was quite difficult. So
Yeah.
any other source from where I can get to those?
No, I mean, I can tell you about which book does it. So there is this book
Yes, yes,
by,
book will work.
there is this book by Alan Templeton, Microevolutionary Theory. Okay.
My okay, okay.
Just give me 1 second. I will give you the microevolutionary theory, Alan Templeton. Yeah. So that gives a very, very nice.
Mm,
uh, अरे यार, oh, there is some mega problem today. Just 1 second. Oh wow, somebody has. Oh, okay. Now they have only given the content part of it. No, I was wondering if somebody has given the entire book or not. No, no, that's not the case. They've only given the content page. Uh, just 1 second. I'm trying to get you the link to the book. Here it is. So, Just did you get the chat, Khushi?
Yes, yes, sir.
Just click on that. That has a very nicely done step-by-step derivation. Hmm. But that is only
Okay.
for your own knowledge. In the context of this course, you don't need it.
Yes, yes.
Hmm.
Okay, okay.
Okay, chal.
Um,
How much have you completed till now?
I am on week 7, that aging concept.
Agings. Okay, okay.
And I would really like to appreciate that derivation of selection you have gone through in 1 hour long video. It was
That.
actually very nice, and I
Hmm.
was really able to get that selection not always increase the fitness. It can decrease also. Otherwise, up to now,
Yes.
I always used to think that if selection is happening, fitness is going to increase.
Yes.
And I
Yes.
also saw that, 3 graphs why fitness is increasing, that over dominance and under dominance. It was quite good to know the behind of all
Hmm.
those.
Good. Good. No, nice to know that you enjoyed it. Yeah, that derivation, although a little, some people who don't have maths background find it a little tough, but it's very insightful. Gives you too much of information in one shot.
Yes, yes. Actually, I enjoy maths also, so I loved the derivation.
Ah, okay, that's why. You have a what, a biotechnology background?
No, no, I have only biology, but till 12th, I was having maths.
Ah, that's why. Okay, okay, great. Ah, Rahul, do you have anything?
Hello, sir.
Hi, tell me.
Um, Actually, sir, I entered a question on the Google form.
Oh, it hasn't come to my notice. Can you please repeat the question?
It was not like I just asked out of curiosity because I worked on mimicry. If you
Hmm.
remember, I have also attended your biostatistics course
Okay.
last to last year.
Oh, okay. You are working in some place in Bihar.
Yes, sir. I am in Magadha University. I am assistant professor.
Right, right, right. Oh, okay. I didn't connect that it's the same person. Okay,
Yeah,
nice to see you. Tell me.
yeah, yeah. I am attending this course just for my freshers to brush up my concepts.
Hmm.
So uh, one thing that came in my mind because I'm working in mimicry and there are there is a famous scientist Fisher. He says that mimicry is one of the best examples of natural selection. In one of the quote, he says that the mimicry it is like greatest post-Darwinian application of natural selection. But when I read the book Origin of Species by Darwin, he does not mention about mimicry anywhere. So wasn't Darwin aware of mimicry? But his contemporary Betts was aware of it.
Yeah, yeah, yeah. See, it's difficult to think that Darwin was not aware of it, given the breadth and depth of his knowledge.
Yes, sir.
See, you remember the way that book got written, right? I mean, he had to write it in a hurry. Otherwise, he would have taken another 10-15 years to write the book. So, obviously, he was not able to include everything into that book, and probably, that might be a reason. I mean, I also don't remember mimicry in that book, so you might be correct. It may
Yes,
not be there. Okay. So, see, just because Darwin didn't write about it in the book doesn't necessarily mean that he didn't think about it.
yes, sir.
Most probably would have thought about it, didn't fit into his argument, which is why he didn't put it.
Yeah, because mimics are quite abundant. We see it everywhere. Like,
Mimicry is abundant.
yes, sir.
Mimics, yeah, that is true.
And rest I am completing the course on my own pace. So I
Where are you? Which week are you in?
yeah, sir, I am still in third week. I have
Okay.
completed second week and third week.
Hmm.
I means the way you discussed about Lamarckism, I did not study like that. I have read from textbooks
Hmm.
and I could not find the account the way you presented. So it was quite interesting.
Hmm.
So Lamarckism was like that, use and disuse only, and we study the typical example of giraffe and all. But
Yeah. It's
but the
actually a lot more than that, huh?
yes, sir. So I am getting to know lots of things here, and also I like you share the video link
Hmm.
where about the journey of Wallace.
Hmm.
So it was also very interesting.
Yeah. See, one of the problems with the NPTEL mode of teaching is that I cannot use the videos as part of my lecture.
Yes, sir.
Okay, so when I teach at IISER Pune, I use the videos as part of my lecture. So, I'll go up to a point, I'll stop the video, I'll comment on it, I will draw their attention to certain things and so on and so forth.
Yes.
But the problem is that, I mean, this is what the NPTEL folks told me, that if you put the video inside as part of the lecture itself, then YouTube takes it as a, issue with the whatever, copyright or whatever. All right. As a result of which the video has to be kept separate and I have to tell you guys to watch it and then come back and so on. Now, obviously, when you are watching my entire thing, then you don't really have the bandwidth to stop, go, then
Yes,
come
sir.
back, etc., etc. So that creates a little bit of a jerkiness. So because of which I have actually used very few videos in my this particular NPTEL course, whereas normally when I teach at IISER Pune I use a lot more videos. Okay,
Yeah,
so
but that video was quite interesting. The
hmm,
only issue, like I didn't face much issue, but I think many students may face.
hmm,
There should be some link in the chat box, kind of some in written somewhere, because it is on the video.
hmm,
So I found it very easily because I typed HMI biointeractive videos like that.
hmm.
So I got, because from video you cannot click on link.
No, that
So
is true, but that is why
yeah,
all the links etc. are given on the website. No, you guys are not looking at the website.
no.
That's why. See, there is a website which is running along with this course. And
Okay,
all
sir.
the links that I am giving, all those
Okay.
links are given in those websites. So
Okay.
if you just have to go and click, that's about it.
Okay.
And what I intend to do is, once this course is over, I intend to put in a lot more extra material for self study and exploration and so on and so forth
Yes.
with the website. So you guys should definitely bookmark the website and keep on coming back at it, because I know that, see, you are going to teach evolution at some point, right?
Yes, sir.
So many of the resources that I am going to put up on the website, those are going to be very useful for you.
Yes.
So
Actually, I'm attending this course primarily for teaching only,
hmm,
because I want to teach students in a different way.
hmm,
Before your course, I have also attended a course on evolutionary dynamics by
hmm,
Supreet Sani. So
IIT Bombay. Hmm,
yeah, last year I attended, and this
hmm,
year I am attending your course.
hmm.
So
Yeah, Supreet's course is a lot more theory oriented.
yeah, it was mathematical also, quite
Hmm.
mathematical,
Right.
and it was mostly related to microbial evolution.
Yeah, that is his core interest.
Yes, sir.
Hmm.
Good evening, sir. Okay, some of my staff members came.
Right.
I wasn't also aware about the story of Wallace, that he lost everything
Hmm.
in his earlier journey. So he started everything from scratch again after going to Indonesia. So
Yeah.
these things are add up. And because my students are from rural areas, so I
Hmm.
narrate all these stories in Hindi to them,
Hmm.
and they
Hmm.
feel it quite interesting.
Hmm.
So in a way, when I teach anything I am teaching them, I include some part of evolution in it.
Hmm.
Like I am teaching them comparative anatomy right now in semester 3.
Hmm.
So I'm also telling them, see how how when we compare the anatomy of different animals, it also shows how animal has evolved from lower level to higher level, how the organs are becoming complex. Like I am teaching comparative anatomy of heart and explaining from transition from two-chambered heart to three-chambered heart to four-chambered heart. So
Mm-hmm.
I mention about evolution everywhere. So so
Yeah, yeah.
yeah,
Hmm.
I always think that because I am not very much specialized in one area.
Hmm.
So evolution, I want to make it a core area. So I am also reading by myself and I am attending courses also.
Mm-hmm. That's a good, strategy.
Yes.
Yeah, no, you should be able to get one or two things that might be interesting for your students.
Yes, sir.
Hmm. So Anish has given the link to the website in the chat box. So you should, simply copy paste that and keep it with you. Thank you, Rahul. Okay, so if there are no further questions, shall we end the meeting? Because it's
Yes,
already,
sir. For now, I don't have any other question.
yeah. I mean, see, we are anyway coming towards the end of the course. So maybe I will organize one more, interaction session. This is the third one we are having, right? Yeah. So 4 interaction sessions, I assume, should be okay. So I'll do one more. So you guys can ask me in that. Okay.
Okay, sir.
Hmm.
Thank you, sir.
Okay. Thank you.
Good evening,
Thanks.
sir.
Yeah.
Thank you, sir.
Good evening. Thank you, Rahul. Thanks, Kritika. Bye. Uh, Karthik, we are ending the meeting. Okay. Acha.